Okay, we shall continue with this chapter 9 homework. We have finished questions 8, 9, 10. Okay, we are going to finish 11, 12, 13. No matter what, we must finish, okay? Because we got other things to cover. So let's do textbook homework. Okay, do continue on foolscap paper. Page 332. Okay, these are the questions we are doing. So let's look at this next one. This next one is uh, on this particular thing. Okay, now let's see in the diagram PLR, okay, QLMN are straight lines, so they are just trying to tell you this is a straight line, this is a straight line, okay. Then PQ is parallel to this, okay. So whatever they tell you, you just verify that, okay, it's labeled. This one parallel, this one parallel, this one, okay. And then you know that, okay, this is 8, okay. It's QL that's 8, not this whole line, okay. So you know that this is 8. This and these are 4, so LM and PL, they are 4. This is 4, this is 4. That means this is actually isosceles. Okay, then MN is 12 and QR is 18. Okay, so we have verified everything on the diagram. Everything is updated on the diagram already, so we can just proceed and do the question. Okay, so what they want us to do for 11 part A part 1 is to name a triangle similar to PLQ. So as I mentioned to you, in order to name triangles, right, it is good to do a rough working such as what I'm going to do now. You do in pencil because this is not a formal working, okay. PLQ, right? PLQ, okay. You see what points correspond to all these, okay. So PLQ is here. So you see, we have learned in the previous lesson that we must recognize a few types of similar triangles. The first one is when there's one parallel line, okay, to the side. Inside here, there's one line drawn parallel to one of the side. Then these two triangles are parallel already. The other one is when you have two lines parallel and then you crisscross the diagonals. You have actually formed two similar triangles again. Okay, same for if you have what you call that, parallelogram here, then you crisscross. This is similar to this is similar to this, okay. And then when you have this is a harder one, but we have actually revised that day. So let us try to see whether there's any of such cases here. Oh, I see one parallel line here. That's why it's very important to update your diagram, but they are very nicely updated for us. This is parallel to this. Oh, that means this parallel line, this line is parallel to this, and these two diagonals crisscross, right? Meaning this triangle must be similar to this triangle, okay. Of course, now we must name them in the correct order. So what I recommend is you recognize that this is the alternate angles, right? Oh, so this P must be friends with the R, okay. And of course this and this, they are friends, okay. So the L and the L, they are friends, and the Q is the friend of N. Okay, Q is the friend of N. Again, alternate angles because this parallel to this. PQ parallel to NR. Okay, so the answer is simply this is N, right? So the answer is simply triangle RLN. That's all. Okay. So you use this method, and then this one is just a rough working. Okay, this pencil thing is just a rough working for you to be able to see clearly. Okay, now you're asked to calculate the length of LR. Now you see, you are not asked to prove that they are similar. No need, right? So no need to prove that they're similar. You just need to know that if these two triangles are similar, okay, then you can write the three ratios, right? But you can don't write also, okay? As I mentioned to you, right, the small over the big, but must be the corresponding sides. You see, PL correspond to RL, right? So these 4 over this LR, 4, I'm trying to write two ratios, okay? Small over big equals to small, okay, must always start with the small, small over big, this ln, okay, and this ln together is 16. Then you can cross multiply, right? So 8lr is 4 times 16, then your lr is 4 times 16 divided by 8, so that will give you lr equals to 8 cm. So that is all you need to do for this, okay? Now we continue with name the triangle similar to NQR. Okay, then we use our pencil again. Triangle NQR. This is a rough working, okay? NQR. Let's see N. N is where NQR? NQR. Oh, big one. Big one. Okay, so then you see you look at the sides, right? Oh, the sides are these. Okay, this line is parallel to this line. But no use. You know why no use? Because we are talking about NQR. Okay, NQR. We are not talking about this small triangle. We are not talking about this small triangle which was earlier, right? If it's this small triangle, yeah, then it's similar to this triangle. So we don't look at this parallel side. We look at this one. We look at this one now. You see, this is parallel to this. Correct? This line is exactly the same as this line, meaning to say it is a case of one triangle, and then inside the triangle you have one line parallel to one of the sides. This kind of cases, okay? One triangle, then one line parallel to one of the sides. Yeah, so this is the one. So we look at this big one, which is NQR, right? NQR, then we look out for the small one. Where's the small one? NSN, no? NSN, see, N and N of this triangle is same as N of this triangle, right? So N and N are the same, okay? Then, because I'm parallel to you, so this is the same as this one, is the same as this one. Okay, a bit confusing, but it's this angle and then this angle, okay, this angle. Okay, so the S and the R, they are the same. Okay, and finally your Q and this M must be the same, so it's NMS. Okay, so your answer, right, for B part 1 is NMS. Finish. Okay, now let's do part 2. MS, where is MS? MS belongs to this small one, you see, NMS, right? If NM belongs to the small one, so you see this triangle similar to this triangle, right? So small over big, small base over big base, you see, small base of this triangle over big base of this triangle, right, will be MS over 18 equals to 12, because we don't know this, right? So we cannot use this, we use this side, 12 of this small triangle over the 12 plus 4 is 16, 16 plus this is 24, so it is 24. So MS, right, when you cross multiply, it will be 9. Okay, so that's how you get the answer. Okay, now let's do the last part. Name 3 other pairs of similar triangles. Okay, so when they say name, we don't need to prove, we just need to name them. Alright, so how to name them? Let me enlarge a bit. Okay, so they say 3 other pairs, that means we cannot use this one cannot, this one cannot already. Okay, now you look for parallel lines. That's the most obvious one. Okay, so now we look at this and this. Okay, this line parallel to this line, right? So PQ and QR, right? Can you see that their diagonals crisscross and they cut at L? Okay, so this angle same as this angle, right? So we can say that triangle P is the same as R. P of this small one, right, is similar to triangle R of the other one. Oops. Okay, wait. Okay, can. P, I'm same as you. So I write first. Okay, if you don't want to write this method that I shown you, right, then you can straight away write this one. Okay, that means I go first, you also go first. Okay, then now L, we are the same. We are the same, right? You and me, we are the same. Okay, then the last one, you must always do the small one first. Small then big, small then big. Okay, then down here we standardize. Q, and then down here is not Q. It's not Q. It's M. Sorry, M. PML, right? PML. PML. Okay, so this is M. So PLM is similar to RLQ. Okay. So that's all for this part. Now you try and spot other similar triangles. This one similar to what? Okay. So we have done this already. Okay. Now any more that are here? Okay. So you see carefully. This line parallel to this line, right? Okay. Can you see any more that are similar? Alright. If you can't, right, then you move on. You move on to others. Now, can you see that this here is actually similar to the other one? Now here, you see here, this because this is parallel to this is parallel to this, right? Okay, so PQR, right? Can you see that? Wait, PQR. P is the same as this angle R here, right? Is it the same? It's the same. So PQR, right? Actually, it's actually the similar to this RSP. Okay, so P corresponds to this R. Q, okay, this angle, this whole angle correspond to this whole angle. Okay, why? Opposite sides of parallelogram. R, S, and P. P, why same as the other one? Again, it is the alternate angles. This angle equal this angle. Okay. Okay. So we have this triangle similar to this triangle already. Okay. Now, can you see another set of angles? Let's say we talk about PQM. You look at the QM here. Okay. Can you see that this, because this line is parallel to this line, so this triangle is similar to this triangle. Okay. Let me write first. P, using the alternate angles, right? Alternate angles is equals to S. Okay. And Q, using alternate angles again, is equals to N. And M, using the vertically opposite, right? They are equal. Okay, so we have 1, 2, 3 sets already. You see whether you can find more. There should be more. Okay, now that's all for this question 11. We now move to number 12. Number 12 of this particular homework. Okay, they want us to now we are doing congruent triangles already. Okay, congruent triangles, if you remember, there are like 4 tests for congruency. These are the 4 tests. Okay, this AAS and ASA, they are actually at the same category. It's just a matter of where the S is located. If it's in between, S is in between the two angles, we call it ASA. Other cases, any other cases where there are two angles and one side similar, right, then it's called AAS. Okay, so we will be looking at this to see how to do this question. Now in the diagram, STU, oh, they are just trying to tell you that these RTP and these RUQ are straight lines. Why must they tell you it's a straight line? They tell you it's a straight line so that, oh, you know that this is parallel, then this is parallel to this is parallel to this, and this whole line is parallel to this also, okay? So similarly for this, they need to tell you this so that you can use corresponding angles later, because these two are parallel, so on and so forth, okay? And then they tell you this is 9, this is 9, this is 7, this is 5. Just make sure that your diagram is updated, okay? Now, for the first question, very simple, they just ask us to identify two triangles that are congruent, okay? So two triangles that are congruent, so you see, can this triangle, small one, be congruent to the big one? No, they are not. They are similar, okay? Can this be congruent to this? Definitely not, because this is 7, sorry, this is 7, this is 9, then, okay, this one is the same, but already, you know that they're not the same already, because these two are not the same as not equals to 9, you see? Okay, so cannot be, okay, so it has to be like these two, very likely, okay, so how do we prove that they are congruent? Now we have to examine carefully first, they tell us, there must be a reason why they tell us this is 90, right? Then you see, oh yes, because of the what you call that, Z, the alternate angles, right? This is 90, this is 90, and this is 90, this is 90, right? Oh, that means we can try to use, probably we can try to use SSS cannot, SSS cannot. Why? We don't know this length, we don't know this length, we don't know this length, cannot. SAS, SAS, actually we know this length, sorry, we know this length, they are shared. Not that we know the actual length, but we know that it's a common length, so we can use this, but we don't know this, you see, we don't know this, so cannot use this, okay? How about AAS, angle, we only know this angle, so we need to know another one, but we don't know, so no use, RHS, it means, this RHS means it's a right, both of them are right angle triangles, and the H means their hypotenuse, must be hypotenuse, is the same, and then one other side is the same for them both. Yeah, it fits the criteria, right? Okay, so we will use RHS, okay? So when you do congruency test, you write this down first in your exam paper. You write SSS, most of the time it's not SSS one, then SAS cannot, then AAS cannot, then you RHS, okay? RHS normally is for right angle triangle, but not all right angle triangles you can use RHS, okay? Because sometimes they don't give you the hypotenuse, then cannot already, alright? Now let's see how we can do this. Number 12, part 1, identify. So identify means you don't need to prove, right? Okay. But can I prove us as a practice for you? All right. I prove. Okay, so you just say, oh, actually you know that the two triangles are triangle. You just anyhow name the first one in the order that you like, so I call it RTS, okay? RTS must be congruent. This is the short form for congruent. RTS must be congruent to PTS, right? Because you must move towards the right angle, then this is common. So it must be PTS. Okay. So how do I prove that they are congruent? The proof right is here. I just show you, although it's not required by the question, we need to practice. So first of all, you say that I'm trying to say that this angle is 90 like this angle, but I need to start from here first. So I say that PTS, right? PTS, this angle is 90 degrees. Then they'll ask you, how you know? How do you know? Then you will say that, oh, because of alternate angles. How come you can use alternate angles here? How come? Oh, it's because SU is parallel to PQ. Okay, so that's how you show the first part. Okay, but you have only shown this to be 90. You haven't shown this. So you must say that this is equals to this one, RTS, RTS also, RTS, also 90. Why? Why? How come you say that RTS is 90? When you write that, right, it means this equal this equal this equal this, okay? How you know RTS equal 90? Oh, then you explain here, lor. You say that RTS is 180 degrees minus 90 degrees angles on straight line. Okay? You just say like that, can already. Can? Because this is equal to 90, which is this. Okay? So we have one right angle triangle already. That means we have the R already. We have the R done already. The R here. Okay? Now we are going to say that, oh, the H, which is RS equals to PS is equals to 9. How we know? Is given. Given also is a reason. You must state the given. Okay? You cannot just say RS equal PS then equals 9, then you don't say the reason. This is the reason, okay? It's given. Given where? Given by the question. Okay? So we have R already. We have the H already. Now we need one more side. Oh, the side is this. Your ST is common, right? ST is common. When we say ST is common, you are just saying that ST, right, is shared by this triangle. It's also shared by this triangle. That means they share this same side. So of course they both have this same side lah. So you have RHS already. Then you say therefore triangle RTS is congruent to triangle PTS. The reason is RHS. Okay, this is the formal proof. If you're asked to prove, this is the correct way to prove it. Okay, but this question actually no need, but we want to know how to do it, so we are doing it here. Okay, now they want you to find the length of UQ. Find the length of UQ and PQ. Okay, how do you do it? Okay, very simple. You see, this is congruent to this, correct? This is congruent to this. Oh, that means this length must be equal to this length. Okay, so you say like that. You say since triangle this one RTS is congruent to triangle PTS, right? Okay, this RT must be equals to PT. Okay, why do we want to know this? We want to know this so that we know that this is like this ratio over this ratio is 1. This is 1 unit. This is 1 unit, right? So this small height over big height is 1:2. Okay. So how does this help us? Because we know that this line is parallel to this line, right? So this big triangle is cut into like 2 by this line that's parallel to this line. So isn't it this case whereby they are similar? One triangle then cut by a line that's parallel to one of the sides. So this triangle is similar to this triangle. Okay, and you see, that's the power of these similar triangles. Is coming away. I'm going to show you the power already. Okay, small over big PQ, right, is equals to small. You see, we don't need to know the actual height. Actual height of this small one. We just need to know that it's 1 unit. This is like another 1 unit. So it's 1 out of 2, right? So it's 1 out of 2. Then you cross multiply. This will be 10 equals to PQ. PQ equals to 10 cm. So that's all, you see. So that's how powerful these similar triangles are. Okay, then I can do the same to here, no? RU, okay, you see, this small one is 7. Okay, you cannot say 7 over UQ, cannot, because you know why not? UQ is not the side of a triangle is the side of a trapezium. Okay, so you must say small length of the small triangle over longer length of the big triangle. So it must be 7 plus UQ. Okay, this part must be very clear. A lot of students make mistake here. Okay, then equals to, you cannot use, I mean you can use this, but I think it's easier to use this. One unit out of 2 units. Then you cross multiply, right? Then you will get UQ equals to 7 cm. Yeah, that's all. That's all for this particular question. I hope you are clear. Okay, so that's all. No, finish already. Okay. So that's this part. Okay, now we go to the next question already. Okay, very fast. We are finally going to finish this homework. Okay. In CAT, in triangle CAT, the big one, CAT. So I told you already, it's normally one triangle. Then they go and draw lines to confuse you. But actually, don't be confused. It's just one triangle. Then inside there are a few other triangles. And then you see, M is the midpoint of CT. M is the midpoint. When they say this, right, you must label here. Same. So that you know that this is 1 unit, this is 1 unit. Okay. M is the midpoint of CT. Okay, we understand already. CAN, this angle equals to this angle. They have labeled for us already. Okay. Now, CP is a straight line. CP is a straight line. Okay. That's perpendicular to NA. They tell us that this is a straight line, so that if this is 90, right, this is also 90, right? Okay, whatever I write down here later, you got to say it one, okay? Explain why CAN is congruent to PAN. Again, it's a congruency test. So let's see what congruency test we can use. We know that the congruence tests are these. Okay, so think about it. Got right angle triangle, very happy. Got right angle triangle, maybe it's this, right? But then no, it's not this. You know why? Because we don't know this. We don't know the hypotenuse. You see, this is opposite this triangle, so this is the hypotenuse of this triangle, right? We don't know this. We don't know this length. You see, we don't know this length. And then this is the hypotenuse of this triangle, right? You see, we don't know this length also, so it is not right. RHS. That's why I told you already. Don't be tricked by this. When you see right angle triangle, it doesn't always mean it's RHS. Most of the time, it is not. Okay. So if it's not, then you see, I know one angle. Then I know this side is shared by this and this. So it must be AAS. Okay. Or is it ASA? That's where it's important. You need to know whether AAS or ASA. Angle. Then there's a side. Then there's an angle. So the side is in between two angles that you know, right? So this must be ASA, not AAS. Okay, I think you got the idea, right? Okay, but first of all, we must prove that this is 90, and we use angles on a straight line. So I'm going to show you here, because they say explain. Explain means prove. Prove that it is similar. Okay, not similar, congruent. So we know that we are using AAS, right? Okay, let me show you how to prove. Okay, now you say that this angle, right, PNA, okay, PNA is equals to 180 degrees minus 90 degrees. Okay, why? Angles on straight line, that is 90 degrees. Okay, and this 90 degrees is equal to CNA, right? Okay, because it's 90 what? Okay, so CNA, how you know it's 90? It's given to us. Given. The question told us what? There, this line perpendicular to this line, so this must be 90, right? Okay. Actually, I can just say this one is perpendicular, so this is 90 also. Okay, never mind. But I follow the diagram because they told me this is 90, so this I'm trying to use angles on a straight line. Okay, so I have the first angle already. You understand? This is the first angle. I'm going to write down the other angle. Then you say, huh? So obvious they give us what? Yeah, they give us, we must still write, okay? We must write it down so that the examiner know that we know, okay? Then you ask you, how you know? How you know? You give me one, you told me, you are the one who told me, yeah. Oh, okay. So angle, okay, but in between there's a side, right? So the side, AN is common. So don't you agree? It's angle, side angle. So therefore, triangle CAN is congruent to triangle PAN. The reason is angle, angle, side angle. Angle, side angle. Okay? I hope you are clear. Okay, so this is how we prove congruency. Hence or otherwise, explain why MTAN is a trapezium. Okay, this part is slightly difficult. MTAN is this one, right? What is a trapezium? A trapezium is a shape, okay, that has one pair of parallel sides. So like that, right, is a trapezium. Okay, like that, with this 90 also is a trapezium. Okay, as long as there is one pair of parallel sides, is a trapezium. So you take a look at this MTAN. Is it possible for this side to be parallel to this side? AN? Not possible, right? So it must be this one parallel to this one. As long as you can prove this one parallel to this one, you win already. Okay? But then you ask me, how to prove that this one parallel to this one? We must use this first part here. Okay? Because it say hence. Hence means you can use this result, or you must use this result. Otherwise, it's normally more difficult. We don't use the otherwise, okay? We use the hence. Hence, okay. They help us by telling us that this triangle is congruent to this triangle. Now, if this triangle is congruent to this triangle, it means that all the sides, this side same as this side, this side same as this side, this side same as this side, right? So it means that this is equal to this. Okay? If this equal to this, what does it mean? What does it mean? Okay, so it means that this it means this okay, this one is a little bit tougher. Okay, so I'm going to do here to show you how to do part 2. I'm going to now show that this triangle is similar to or rather this length and this length same, this length and this length same, and this one same. That's why this must be parallel to this. Okay, why I say, what are you talking about? Okay, I'm trying to now use this. Use what? Use this SAS similarity. I told you already in the exam, this very often, this can come out also. These two are more commonly tested than this one. Okay, so I'm going to prove that these two triangles, small one and big one, they are similar. Okay, I'm going to prove this. Okay, then you ask me, how? I cannot use angle. Cannot. Why cannot? Because right now I only know that this angle MCN this angle, right, MCN of this small one, this angle of this small one is equals to this angle of this big one. Everybody agree, right? They are the same angle. So MCN equals to TCP. Why? Common angle. Okay, so now we have this A already, A, the common angle. Now these two, right, they are not equal in length for similarity. Cannot be equal in length. You see, how can this small length be equal in length to this one? How can this small length be equal in length to this big one? Cannot be, right? But they are in the same ratio. Meaning what? Meaning this. Okay, I'm going to write down now. CM, right, over small over big, over CT equals to 1 out of 2. How I know? How I know? Oh, because M, they told us what is the midpoint of CT. M is the midpoint of CT, right? So of course, if this is 10, this is 10, then this is 10 over 20, so half lor. If this is 1000, this is 1000, so it's 1000 over 2000. So no matter what, as long as they are the same, right, it's half already lor. Okay, small over big is half. Can? Okay, now I'm going to show you see I have one side that is I have one pair of sides that is in the ratio half already. If I can show that this side this pair of corresponding sides also in the same ratio half, right, then I win already lor. I can use SAS already. Alright. So now I'm going to show CN. CN over CP also half. How we know? How we know? Oh, from the earlier part. Triangle CAN congruent to triangle PAN. Okay, you got it? Okay, so this is your SAS. I see, this is your one pair of similar one pair of corresponding sides equal to the other pair of corresponding sides. So this is what you need to write. CM over CT equals to CN over CP equals to half, right? Therefore, triangle what AMC small over big what's the reason? SAS, but you must say SAS similarity. Okay, similarity. Why? Because there are two SAS. One of them is congruence test, the other one is a similarity test. So you state similarity here. So that's all. And because this one is similar to this one, this one similar to this one, right? Therefore, so my this CMN, right? This angle here, okay, let me mark down. This angle here, because this triangle is similar to this triangle, right? So these two angles must be the same, right? For similar triangles. So now you can say that therefore by alternate angles, by corresponding angles, this is corresponding angles. That's why you see I ask you to learn all those corresponding angles, all these things, right? Only can be used for parallel lines, right? Okay. So if this equal to this, then this definitely must be parallel to this. That's what we're using, okay? By corresponding angles of parallel lines. Okay, by corresponding angle of parallel lines, MN must be parallel to TP, okay, which is TA lah. Okay, because this is a straight line. Okay. Therefore, MTAN is a parallelogram. No, not parallelogram, sorry. Trapezium. As it has a pair of parallel sides. Okay, we'll end here today. I just want to tell you what we are doing next tomorrow. Okay, we are going to do this worksheet that you have for your BCD. Okay, I'm going to go through this the next few sessions with all the homework and all that. We'll be doing some of the chapter 10. Okay, the chapter 9 homework I won't be doing. I've done quite a few already. I'm going to do the chapter 10 homework using this. Alright, so if you want, you can try this first. Thank you.